Unit 3A, Part 2. We'll look at describing three types of memory, identifying the relationship between novice-expert differences in optimal chunk size, and we'll recognize the importance of transfer. Let's go back to Figure 3.2, Row 2. This is the row that explains information processing theory. Information processing theory describes how information travels through memory. The first two types of memory that you see identified here are sensory memory and working memory. Both of them are considered short-term memory because they're extremely limited. Long-term memory has an infinite capacity. The red boxes represent sensory memory because it attends to a lot of information in a very short amount of time. And you can see that just only one little red information bit is breaking through the barrier between sensory and working memory. The orange boxes represent working memory, which holds the selected information from sensory memory for a few more seconds. Let's look now at the design advice that is associated with information processing theory. One piece of advice is to tap into knowledge with analogies. An analogy will provide a schema or structure that will make it much easier for a learner to accommodate and assimilate new information. Practice makes perfect is the idea that if you give learners the chance to practice and think about and rehearse and elaborate, you're going to keep the memory alive longer. And then there's information to chunk information into smaller units. And a rule of thumb is that memory won't hold more than 4 to 7 units. But a unit size depends on expertise. And it's important to understand that expert chunks can hold much more information than novice chunks. Let's look at some examples of chunking. We see the power of chunking everywhere. If you look at this wall of words right here, it's a taco recipe. It is not chunked. There's about 100 bits of information there in the form of words. In order to make that taco recipe easier for a person to process, it helps to chunk it. And what you'll see here is that that recipe has been divided into 3 chunks. And you'll also notice that each chunk is often divided into chunks. Also, let's look at this poster, and in this poster we've got chunking. It's the writing process, and it's divided up into the stages of the process: brainstorming, writing, conferencing, editing, and revising. And here you see the pages in a chapter in a book. A telephone number is an example of chunking. The average telephone number has 10 numbers in it, so that's above the 7 plus or minus 2 rule. And the way we handle that is that we divide the phone number up into 3 sections. Let's now identify the relationship between novice and expert differences and optimal chunk size. Among other things, the path between what is remembered and what is not is partially determined by chunk size. Novices will require many small-sized chunks. Experts will require fewer chunks, but each chunk will include many more elements. Let's look at an example of a novice schema. This is a child schema, and it has 3 elements in their schema. And if they were looking at or trying to learn color, you might, as an instructional designer, chunk the data to sort of go along with what you think their schema consists of. So here, if you're creating a page in a children's book, you have one chunk, which is the page, and within that chunk you have 3 bits of data. Now instead, if you were looking at an expert page, you would see that there's quite a bit more information on the page, and the associated schema has quite a bit more information or information bits within it. So let's compare the novice schema to the expert schema. Let's now look at the importance of transfer. We strive to identify optimal chunk size because it is the size that facilitates transfer. Okay, a child sees a page with the word red. So that's what's in sensory memory. And on that page, there's a picture of a strawberry and the word strawberry. At that point in time, the child knows what a strawberry is. So you see that there in their long-term memory. But when an adult points out the words red and strawberry, the child may notice those words. And so what happens is that the child has selected those words and they're held in working memory. Their long-term memory awakens and schema is formed. So you can see that the words in working memory actually transfer to long-term memory. So this page is an optimal chunk size for the child. You have 3 bits of information in one chunk. And the movement of information from the book page to working memory and then to long-term memory and richer schema is called transfer. And transfer is our goal. When information transfers to long-term memory, it can be used at a later time. So let's say our child is older and they're taking an art class and they see this page in a book. They know already what red is and what blue is, and they have a representation of that in their memory. When their attention is focused on the words blue plus red, and they see the color that these 2 tubes of paint have mixed into, which is purple, that information is represented in their working memory. So their working memory is taking in what they are seeing in sensory memory. And it's taking in almost all of it because it's a good chunk size. And this is because their long-term memory has those data points that help them understand what blue and red are. Schema eventually is activated, and now they know that purple is made from blue and red. So if the child had this schema and they saw this page in a book, working memory would be overloaded and long-term memory would not have anything clear to grab a hold of. So this is why it's so important to chunk content into an optimal size. Transfer of optimally chunked information to long-term memory will help the child learn additional colors and their relationships. So let's see what you've learned. Complete this sentence. We strive to identify optimal chunk size because it is the size that facilitates transfer of learning to long-term memory. Getting the proper chunk size helps the designer increase germane load, and it helps decrease extraneous load. So we've described 3 types of memory. We've identified a relationship between novice-expert differences and optimal chunk size. And we've recognized the importance of transfer.